Hello everyone, welcome to Deeksha Karnataka. I am Deeksha Kaushal, your chemistry master teacher. So in this doctor's batch, we are doing the most important chapters along with the theory and questions. So we'll be doing concepts and PYQs both here for coordination chemistry. In the last lecture, I did it for chemical bonding, right? And today we are going to do the questions of NEET and the topics, the concepts of coordination chemistry. Do let me know in the chat box, guys, if I am clearly visible and audible to all of you or not, so that we can start with the session. Yes. Do let me know, everyone. Very good afternoon, Roshi, Basi, Basling, Gappa. Patil. Yes, Karthik, Chandana, Tawfiq. So I was waiting actually for the other live to end, but uh, then I thought to start the class now onwards, right? Okay, so everybody do let me know. I just want to see your like hello highs in the chat box, right? Because even I am getting out my precious time for you guys here, right? So all I can expect is your replies. That's what I can expect from you, isn't it? Tell me, isn't it visible? Perfect. Very good, Roshi. Okay, let's start with the class now. If I talk about coordination chemistry, guys, in coordination compounds, there are some very important topics. Firstly, let's see what are the topics that we are going to do. First is Werner's theory. From Werner theory, it's a very simple theory, very simple theory, very straightforward question they ask. Then mostly they ask questions from VBT. VBT, they ask questions on shape, hybridization, then magnetic moment. So these three questions, it is a sure short question in your exam. Definitely out of this VBT question will be there in your exam. That is a sure short question. Then the next topic is CFT, from where sometimes they ask question from CFT, sometimes from Werner. Right, this switch topic, and sometimes isomerism. They are not very sure short, but like you can expect around in coordination chemistry. In NEET, they ask 2 to 3 questions, or sometimes it also goes up to 3 to 4 questions in your exam, right? 2 questions to the minimum will be there, 4 questions or 5 questions to the maximum. 4 I would say is a safe score here. 2 minimum and 4 maximum questions are asked from coordination chemistry, and out of this VBT theory is a must question that you will definitely see. You pick out any exam, any question paper where you have coordination chemistry, you will definitely see a question on this VBT theory, right? Wait a minute. Okay, right? Now let's start with Werner's theory. Now when I talk about Werner theory, in Werner theory, bacha, we talk about 2 kind of valencies. One is primary valency and other is secondary valency. Primary valency is oxidation number, secondary valency is coordination number. Now how do you calculate the coordination number or oxidation number? For that, we will go through this one thing here, that is denticity. Right, now see, denticity means the number of donor sites that it has. A ligand, now if I talk about coordination chemistry now, if I talk about coordination chemistry, now in coordination chemistry, what you have here, you have a metal, right? This is the central metal atom, this is the central metal atom, right? This is the ligand, this is the ligand. Now, center metal atom will always accept the electrons, and the ligands are always going to donate. This is always going to accept, and this is always going to donate. Ligand is always going to donate, right? And this whole thing, this full square bracket, is called as coordination sphere, right? And outside this coordination sphere, the ion is called as counter ion. It is called as counter ion, right? Now, if I want to understand how to calculate the oxidation number and coordination number, you must go through firstly denticity here. If I say what is denticity, then let's talk about this. Denticity means number of donating sites. Donating sites. How many donating sites a ligand has? Because ligand is donating in nature. It will donate the electron. So how many sites it has? Now if I talk about monodentate, that means one donating site. One donating site. One donating, I'll just write one here, right? It means it will have one donating site. So in this neutral means where charge is zero, you have ammonia, which has, because of these lone pair it is donating. Water, because of these lone pair it is donating. Site is only one. Lone pair are two, but site is only one. Carbon monoxide, it donates from this oxygen here, right? Then pyridine, it donates from the nitrogen in the pyridine, right? Then these are all the neutral monodentate, right? Then -1 means which has -1 charge. Azide N3 negative, bromide, chloride, cyanide, fluoride, all these are -1 charge. They have only one donating side, but the charge is -1 here, right? Then next is monodentate with -1 is hydroxide, nitrite, NO2 negative. These are very important. If you don't know this table, you will not be able to do any, like VBT also you will not be able to do, CFT also you will be not also not able to do, IUPAC also you will not be able to do. So anything you will not be able to do if you don't know this table, right? So thiocyanide, that means SCN negative, again one donor site with negative charge. Now bidentate means two donating sites, two donating sites. So here we have neutral, in the neutral we have bipyridine, right, which very rarely you will use this. Ethylene diamine, this is a very famous structure, ethylene diamine. Ethylene diamine means you have ethylene, CH2, diamine means NH2 is connected to this ethylene, that is ethylene diamine. And here this ethylene diamine has two donating sites from where it is donating to the metal atom, right? Okay, this is very important, right? Then -2 carbonato oxide, that is O2 negative, oxalato sulfate. Out of this, oxalato is very famous. So what we draw in oxalato, we say C double bond O negative, C double bond O negative. This is oxalato, C double bond O negative, C double bond O negative. And the donating sites are, these two are the donating sites, right? Okay, can you see that these two are the donating sites here? That is why it is bidentate, two donating sites here. Acha, now I'll tell you, now see this thing, I am marking the most important and most frequently used ligands here. These halogens you will see most frequently used. Cyanide is also very frequently used. Water, ammonia is also very frequently used. Carbon monoxide is also used, but not that frequently, but yes, it is used, right? Then you will see in your syllabus nitrite also you will see in the exam. Thiocyanate also it is used, yeah. So carbonate is also used. So these are some of the very famous ligands that you have. Is that clear, everybody? Tell me. Very good afternoon, Karthik, Samarth, Khushi. Very good afternoon. Now tell me, is that clear to all of you or not? Right? Acha. Now see one more thing. Just like you have bidentate, you have tridentate, means 3 donating side. Tetra means 4. Penta means 5. Hexa means 6. Now see this thing. I'll just draw this EDTA, right, for you. See, how do you draw this? Okay, I'm gonna draw this also for you because you might feel that this is actually tough, but it is actually very easy to draw. So if I say I am drawing oxalato, how will I draw? I'll draw one carbon, double bond O, double bond O. This is O negative and this is O negative, and these are my two donating sites, right? Okay. Now if I have to do ethylene diamine, how will I draw it? I'll draw it like this. CH2 is ethylene. Diamine means two ammonia is attached, two NH2. This is NH2 is attached. And these are my two donating sites here. That is why these are bidentate, 1 and 2 donating sites. Now see what is EDTA. It is called as ethylene. Ethylene, firstly draw ethylene. Ethylene is CH2, so I'll just draw it here. Ethylene, right? Then diamine, just like this, draw diamine, right? You have drawn ethylene diamine, that is ED, ethylene diamine. TA means tetraacetate, right? So that means what you have to do here, instead of the hydrogens here, you will place acetate group, that is CH3COH, right? CH3COOH. CH3, I'm just replacing the hydrogens with the acetate group here, CH3COH. Now see one thing here, very important, very important. Now in these two, you will see only two donating sites. One is this one, other is this one. Only two donating sites, right? Can I mark it? 1 and 2, two donating sites here, right? Now if I say EDTA with zero charge, see, very important thing, if it is with zero charge, that means they are saying ethylene diamine tetraacetic acid. This is acid. It is not an ion, it is acid, right? So EDTA with zero charge has two donating sites, it is bidentate. Let's say, ma'am, I want to have EDTA with a minus charge. Minus charge means one H will go from here. That means one O negative and one minus here. Now 1, 2 and 3 donating sites tetradentate. Ma'am, I now want to have 2 negative charge. That means 2 negative means 2 hydrogens will go from here, right? That means 1, 2, 3, 4 tetraacetate, right? Tetradentate. Now if I say 3 negative, that means 1 hydrogen will go from here. This will be 1, 2, 3, 4, 5 pentaacetate, right? If I say, let's do one more thing here. Let's remove one more hydrogen here. Total the charge is 4 negative, right? And that's how it is hexadentate. If they have mentioned the charge specifically, then you will see how many donating sites you have here. If they have not mentioned the charge here, then what you will do? Then you will just see ethylene diamine tetraacetate ion. If it is ion, that means all of them has negative. If it is written acetate, that means they are talking about EDTA 4 negative only, right? Okay, got it? Yes. Now next thing is two kind of ligand. One is ambidentate, then there is flexidentate. Ambidentate ligand is two donating sites. So what exactly happens in ambidentate? It has two donating sites. The donating sites are two, but only one used at one point. That means, like you have here, you have two donating sites. Sulfur can also donate, nitrogen can also donate. But in one particular compound, only one will donate here. At one point, you can only use one. Right? Like here, nitrogen can also donate, oxygen can also donate. Here, carbon can also donate, oxygen can also donate. So all these are ambidentate. They have two donating sites, but at one point they will use only one donating site. Okay. Flexidentate ligands are having two or more donor atoms coordinate with metal. Two or more donor atoms are there. either through one donor atom forming non-chelated complex or through donor atom forming chelated complex. That means they are saying flexidentate means sometimes the ligand they try to form chelate complex, sometimes they don't try to form chelate complex. Ma'am, then what is chelation? For chelation, you should know what is chelation. For example, this is your oxalato. This is O negative, this is O negative. When it is forming this, when it is donating to the metal, right, it is forming a ring here. And that ring means it is forming chelate complex. And chelate complex are always more stable as compared to non-chelate complex. So chelate is a type of complex where central metal, right, is bonded to large organic molecules called ligand, forming a ring-like structure. And flexidentate is sometimes this, if you say sometimes is oxalato try to form chelate, sometimes it is like, okay, even if I don't form chelate, that will also work. So that kind of thing that we are talking about, right? Okay. Now let's go back to Werner's theory. We were talking about here one thing. Let me just discuss the complex here. That is CO NH3 6. This is Cl. I think it is 3, right? Okay. Now see this thing, bacha, very carefully. See this thing. What we have here. I'll calculate the oxidation number and the coordination number. So oxidation number, coordination number is quite simple. Coordination number is quite simple here. Coordination number means in ammonia you have one donating site, and the one donating site means one. You have 6 donor atoms. 6 ammonia means into 6. So total 6 is the coordination number here. To calculate the oxidation number, you will have to do something here. That is, I'll tell you what to do here. Now here what we will have, see this thing. If here you have 3, because always in chemistry, cation is written first, anion is written later on, right? So this is 3, this will be 3 negative, and here that is why it will become X. That means this is X, this is neutral. Ammonia is neutral. We have discussed it in neutral ligands, right? So it is plus 0 equals to minus of 3. Wait a minute. Not plus 0. Wait a minute. Minus how it is. Achha, plus. I'm so sorry, guys. Cation first, then anion, right? So it is 3. It will become plus 3. It is 3. It will become plus 3. Okay, cation, then anion. NaCl also you write it like this. This is positive, this is negative. So always cation first, then you have an ion, right? So it is x plus 0 is equals to plus 3. So x is equals to plus 3 here. That means the oxidation number is plus 3 here, right? So that's what we want to say. Primary valency, that means oxidation number is 3 here and secondary valency is 6 here. Got it? Now let's see what kind of question they can ask. The primary and secondary valency of this compound they are asking you here. How to do it? See, firstly if I see, chlorine is also monodentate. This is also monodentate. So coordination number, that is coordination number is the secondary valency, right? So I can say secondary valency, that is coordination number, that is equals to 5 for ammonia, 1 for chlorine, that is 6. Primary valency is equals to what? That is x plus 0 for ammonia minus 1 for chlorine. This is 2, so this will become plus 2. So it is going to be x is equals to plus 3. So primary valency is 3 and secondary valency is 6. So answer is going to be D is the correct answer here. Now moving forward here, one more thing that we discuss in Werner theory is that let's say they are saying that it gives 3 mole of AgCl. 3 mole of AgCl means, I will just write it one by one. If I talk about, this is the compound A, this is B, this is C, this is D. So what will be the compound A? If 3 AgCl are outside, that means 3 Cl will be outside, because inside, whatever is inside the coordination bracket will not get dissociated into ions, outside will get dissociated into ions. That is why 3 AgCl will be formed, right? So this is CO, 3 Cl you have used, this you have used, you are left with 6 ammonia, and this is the compound, right? They have asked questions based on this, right? So B, here if I say 2 mole of AgCl is outside, that means 2 Cl will be outside here, right? Now 2 Cl is outside, cobalt I have used, that means 1 Cl is inside, 3 Cl I have used, that means here you will have 5 ammonia. This is the compound here, right? Okay. What about C or D? Here you have 1 mole of AgCl, that means 1 mole will be outside, other 2 will be inside chlorine. Chlorine will be acting as ligands, and here you will have ammonia 4, because here it is 4 ammonia, here also it is 4 ammonia, and this is cobalt, right? Okay, got it? Tell me. Okay, acha. Now let's see. This I have already told you, 1 ratio, 2 ratio, 3 ratio, what is it? We have already discussed about it. Now the question is, ma'am, when both of them have same formula, why we are saying this is green in color, this is violet in color? This is green, this is violet, because of isomerism. They have the same formula, but their structural arrangement is different. That is why they exist as isomers. That is why the color is different, right? Okay. This we have discussed, that when 1 ratio 3 means this is 1 and this is 3. So 3 Cl outside. This means this is 1 and this is 2. This is 1 and this is 1. This is 1 and there is no ratio here. So only no dissociation. No dissociation, right? How many ions it is giving, right? Now let's discuss a question based on this. The correct order of this is 2017 question. AgCl formed when AgNO3 in excess is treated with complex like COCl3. These are the 3 complexes which are being reacted here, okay? Okay, so they are saying the correct order of stoichiometry of AgCl when Ag excess is reacted with these complexes. So first you have to draw the complex. Cobalt with 3, ammonia is 6 here, and that means 3 Cl will be outside. Then you have cobalt, 5 ammonia you have. To make the coordination number 6, you will use 1 Cl inside and 2 will be outside, right? Here you have 4 ammonia. So cobalt, here you have 4 ammonia inside. That means to make coordination number 6, 2 should be outside. This will be your number here. Now, if you see this here, we are saying that here 3 AgCl will be formed. Here 2 AgCl will be formed and 2 Cl outside. Here 1 AgCl will be formed. So I can say 3, 2, 1, that is B is the correct answer here. Quite a simple question from Werner's theory, right? Okay. Yes. Akhil, see, it is possible definitely, right? But you have to, go through the lectures that I am teaching, because chemistry is the most scoring subject. In physics, I really doubt it, but chemistry can definitely boost your score here, right? Okay. Now let's see other questions. Which complex is most stable here? Now this stability is actually based on the chelation. If you see, there is only one bidentate ligand, that is En here. There is no other bidentate ligand. Because it is bidentate, it will form a complex like this is 1, 2, 3, 4, 5, 6. 6 coordination. See, firstly I'll also write the coordination number. This is 3, 3. This is coordination number 6. This is 2 and this is 2 into 2, 4. This is also 6. This is also 6 and this is also 6. Here this is the bidentate ligand. This is bidentate ligand means here the complex will be formed like this. En, because it will form a, see En how? This is nitrogen, this is nitrogen, this is ethylene diamine, right? This is nitrogen, this is nitrogen, this is ethylene diamine. And here you have Cl, here you have Cl. So definitely it is making 1, 2, 3, 4, 5, 2 5-membered rings. Two, you can say 2 5-membered rings. So definitely it is showing you chelation and chelation. Chelate complex are obviously more stable, so answer will be B. Right? Okay, so again, NEET 2023 question based on a very simple concept called chelation. Right? Okay, yes, everyone. Let's talk about this here. Ethylene diamine tetraacetate ion. Now tell me. Now, bacha, as I told you, NEET 2024 question. Can you see this over here? Right? Ethylene diamine tetraacetate. They are, now you will think, ma'am, they are talking, they have not given any charge. Bacha, they have given tetraacetate ion. That means they are talking about the simple 4 negative charge. Right? So this is nothing but this is N. Ethylene diamine means here you will have CH2. CH2, right? Here you have N. Tetraacetate means 4 acetate ions you will have. 1, 2, this is the third one, CH3CO negative, and this is the fourth one. Can you see how many sides are there? This is 1, 2, 3, 4, 5, 6. So it is definitely hexadentate ligand. Right? Which one? This one you want me to repeat? See, Vacha, here we are saying that if I talk about chelation, you just need to find out the chelate complex here. Right? Chelate complex is oxalato is chelate complex. Bidentate, see, chelation can only be shown by those compounds which are having more than one donating sites. Okay. So this has one, this is also monodentate. This is also monodentate, so no chelation effect can be there. This is also mono, but this is bidentate. This is also mono. This is also mono. This is the counter ion. This is also mono, right? And this is also mono, and bromine is also mono. So only En is the bidentate ligand, right? It is donating through 2 nitrogens here, right? This is CH2, CH2. If I want to write it clearly, ethylene diamine, this will be CH2, CH2. So I have just written it like that, CH2, CH2. Can you see 2 rings are getting formed here? That is why. Okay? Tell me. Understood? Is that clear? Okay. Now let's talk about this. This I have already discussed. Now next one is, which of the following is not a ambidentate ligand? Ambidentate ligand means they should have 2 donating sides, but only one will be used at one point. So this is ambidentate, this is MB, and this is also MB. This is oxalato is not ambidentate ligand. It is it has 2 donating side, but it use both of them. It is bidentate ligand, right? Okay, so answer is A. Absolutely correct, Roshi. Very good, right? Okay. Next one is, the next question you can see here. See, I have till now not even started VBT theory, but you can see this over here based on simple definitions. They have asked questions here. And this is one of the most important chapters of chemistry, right? So, CONH3 positive is homoleptic complex, whereas this is hetero. Now, ma'am, what is homoleptic, heteroleptic? Homoleptic means one kind of ligand. So it is only one, and here it is 2 kind. That is why it is hetero. So this statement is true. Complex CONH3 has only one kind of ligand, but this has more kind of. That is also reason. That is also correct, right? And if they ask, this is assertion, this is reasoning, then reason is the correct answer for the assertion as well, right? So you can say both the statements are true here, right? Okay, both the statements are true here. Got it? Now let's talk about IUPAC naming, because based on IUPAC naming also by elimination you can easily do the questions. Okay, so very simple it is. And I'm not at all saying cram full ligands and everything. In IUPAC naming, by elimination only you will be able to do the questions. I'll show you how by elimination. If you know little bit rules, you will be able to do it. Right? See. The cation is named first, both positively and negatively charged coordination, always cation first, then anion. Ligands are named in alphabetical order A, B, C, D, alphabetical order, right? Names of the anionic ligands always end with O. That means chloride will be called as chlorido, bromide as bromido, iodido, cyanido. Then you have oxalato, right? So always it will end with O, right? Negative ligands. Cations are same. For water you use aqua, for amine you use, for NH3 you use amine, and for CO you use carbonyl, and for NO you use nitrosyl, right? Okay. Then prefixes mono, di, tri. For example, you have 3 ammonia, so you will write triamine. If you have 3, if you have 4 water, you will say tetra aqua. Okay. But let's say you have ethylene, diamine. This is the name of the ligand. Now let's say you have 3 diamine, ethylene diamine. You cannot, if you write tri, this will be wrong here, right? Then you have to use bis. Bis for if you have 2, tris if you have 3, then tetrakis if you have 4, pentakis if you have 5. And this will be in the bracket. Okay, if in the name of ligand itself you have di, tri, tetra, right? Oxidation state you will calculate and you will write it in Roman numeral, right? Then if coordination complex is cation, very important, if coordination complex is cation, on this you have positive charge, then the metal is named same. But if the complex is anion, very important, then metal ends with suffix ate. For example, ferrate. For iron, you will use ferrate. For silver, you will use argentate. That is a Latin name of silver. For cobalt, if it is in a cation complex, it will be cation. It will be cobalt. If it is in an anion complex, it will be cobaltate. Or you can say chromate. Chromium, if your coordination complex is in the cation state, then it is simple chromium, otherwise it is chromate, right? Okay, now let's talk about, with the help of examples only you will be able to know this, right? Now let's see this one here. How do you answer? See, first is this coordination complex is cation, right? Firstly, I will write the central metal atom cation. Firstly, I'll write central metal. Firstly, I'll always write ligands here. Here it starts with amine. Here it starts with aqua. So this AA are the same only. Then because two words are same here, then we'll jump to the next word, that is M and Q. So M is before Q, so that is why we'll write amine first and aqua after. So it is triamine, triaqua. So it is triamine, triaqua. Then this is in the positive complex. This is 3, so it will be plus 3, right? That is why we can say chromium. Now what is the oxidation state of chromium? That will be X plus 0 for ammonia, 0 for aqua is equals to plus 3. So it is plus 3. That is why we have written in Roman numeral, that is plus 3. Then after this counter ion, you don't have to write tri or tetra, nothing. You don't have to write anything on counter ion, just write chloride, right? Let's talk about this one then. Here this is ethylene diamine, and whenever in the name of the ligand you have di, you don't write tri-ethylene diamine, instead you write tris. So that's why it is tris ethylene diamine or ethane 1,2-diamine, that is the same thing only, right? Then you write cobalt here, oxidation state is X plus 0. Here it is 3, so it will be plus 3. Here it is 2, it will be minus 2 here, so it is equals to plus 3. Oxidation state is plus 3, and this SO4 is nothing but it is sulfate ion, so you can say sulfate here. Right? What about this one? Here, this is the coordination bracket, this is the coordination bracket. If I say silver is usually famous in +1 oxidation state, if I put +1 here, this is 0, this overall will be here +1, right? If I put +1 here, it is -2 for cyanide, it is going to be -1, so overall it is -1. So we can say this is cation, so it is diamine, because in the cation silver is named as it is, so we will write silver only here, right? So silver one. Here it is dicyanido or cyano also you can write, but here because the complex is ion, complex is an ion, so we will write 8 in the end, and I told you this will be not silverate, it will be written as argentate. That's why I have specially written argentate and ferrate for you. Right? Now the kind of questions that they ask from here is IUPAC name of the complex. This beta we have just done. Okay, NEET 2022 question it is diaqua silver 1. Okay, the oxidation state is 1. So I'll tell you in the exam how you will do it. Silver is oxidation state is 1, so these two are already eliminated, right? Here it is 1 and here it is 1. You will firstly write the cation part, that is diaqua. So this is diaqua, this is silver, and this is dicyanido argentate. So answer will be D is the correct answer here. Right, everybody, do let me know if that is clear. Now I think we shall start with this thing. Wait a minute. Yeah. Chalo. Now let's start with VBT theory. Let's start with VBT theory. Karthik, tricks na. In NEET you should apply less tricks here. I would not advise you. Sometimes tricks get more complicated than the question, than the actual method itself, right? So I have given you trick for MOT, right, which was actually trick was used and applied there, but here you don't as such has any trick. Otherwise you will end up doing the mistakes in the question, right? So here this is actually valence bond theory. Valence bond theory. So I will firstly directly tell you that what exactly we do here, right? In the valence bond theory, we'll talk about two things here, right? First is when the coordination number is 4, second is when the coordination number is 6. If the coordination number is 4, you have two possibilities. Either it can be DSP2 or it can be SP3 hybridization, only two. Here it is square planar. Here the geometry is square planar, PLANAR planar, right? And here the geometry will be tetrahedral, and this is a very famous question, right? Okay. In coordination 6, there are only two possibilities that you have. First is D2SP3, other is SP3D2, right? Now D2SP3 is inner octahedral because d orbitals are inside. Both are octahedral only. This is inner octahedral, right? And this one will be outer octahedral. Okay. We have so many examples of this one. As you can see this over here, but what you need to do, usually they ask you coordination number 4 and coordination number 6. Others are not asked to you, right? Okay. Now, so you just need to go through this. So what I'll do here one by one, instead of this, I will do this thing here. I'll just show you how to solve this in the exam, okay? We'll just see how to solve this in the exam. Otherwise now, If you don't solve this now with me, then it will be very difficult for you to solve it in the exam, because there is no as such theory. There is what we have here. I'll tell you that why for this example it is this, why for this it is square planar, why for this is it octahedral. So we'll talk about this, right? So what you need to do is you need to understand the steps here, right? And to understand the steps here, what we will do here, before understanding the steps, there is one thing that you should know, that is, wait a minute, that is what to do. Should I do it here? Chalo, I'll just take one extra page here for that. If you don't know the coordination, if you don't know the electronic configuration of 3D elements, already messed up situation will be there, right? So you must know how to, electronic configuration should be on your tip. So I'm writing it in a very simple way here. See, so what I'm writing, just remember the 3D series, Sakti Karman, whatever, however you have learned it, right? So that is best. Whatever mnemonics you have used to learn it, that is the best. Karman Fiko Niku Jan. This is a full-fledged 3D series. Now we will see in 3D series what exactly we do here. You have 21, 22, the atomic number is 23, 24, 25, 26, 27, 28, 29 and 30, right? Acha. Now, then you must know that here exactly what we do. Here we put electrons in 4s and 3D, and I don't have an option to copy paste this, right? This is 3D, this is 4s 3D, 4s 3D, 4s 3D, right? Again 4s 3D. Now just fill in the electrons just like your atomic number. Now this is for all those students who don't remember 3D series, okay, who don't remember the electronic configuration, just write 3D. This is 21 to 30, write the number here. Now this is 21, write 21. This is 22, write 22. This is 23, write 23. This is skip for chromium and copper, mark a cross, because these are the exceptions. For 25, write 25. For 26, write 26. For 27, write 27. For 28, write 28. For 29, as we have marked, there should be a cross here because copper and chromium are exceptions. Okay, these are the exceptions that you have. So then it is 30, but you cannot do 30 here because in s orbital maximum 2 electrons can be there, and here maximum 10 electrons. Now here what we will have, here instead of 2 4 it is 1 5 because of half filled configuration. Here instead of 2 9 we have 1 10. Okay, understood? Acha, now okay, difference will, the difference is that here I am teaching for NEET students, there I teach for JEE students, right? That is the difference. Acha, see. Now, if you see this here, see this here, see this. This all we have done. Now, if you really want to be fast in your exam, right? Now, you should be that much quickly you should do this. For example, you're saying, ma'am, for nickel, what is? I'll just say nickel and then I'll tell you the electronic configuration. You should be that much quick, right? Nickel 2828, right? Cobalt, it is 2727. Then manganese, it is 2525, right? Then scandium, it is 2121. Let's say you are saying, ma'am, copper, it is 110 because it is 29, but it will be 110, right? You can see this over here, okay? I am not looking at it. Then you say, ma'am, what else? Yeah, iron 26, 4s2 3d6, okay? 2626. So that's how it should like be in your head, right? That much quickly it should be in your head, right? So now let's see what you need to do here. Very simple VBT theory will do. Firstly, what you need to do, first you need to see the oxidation number. First step is to calculate the oxidation number. This is X plus 0 because CO, CO is carbonyl, it's a neutral. That's why I told you that this particular table that I have shown you here. This table now, I have shown you one table here. Wait a minute. This one table I have shown you here, right? This table. This is extremely important for you. Why? Because everything is there, which is -1, neutral, +1. Names are also there. That's why I have shown you that table. Right? Okay. Now see this, X plus 0 is equals to 0. So here nickel is in 0 oxidation state, that is 4s2 3d8. Right? Okay. Now if you see this here, you will always see for coordination number 4, this is 3, 1, 1, 2, 3, 4, 5. This is S and this is P. Right? Now to fill overall, here are 10 electrons here. To fill 10 electrons, you will be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? And you are left with, you need to see the boxes that are empty. So here you have sp3 hybridization. First point, it is tetrahedral. Second point, no unpaired electron. If unpaired electron is 0, mu is also equals to 0. Right? Magnetic moment is also equals to 0. Right? Let me just also show you about the magnetic moment here. If you see, diamagnetic means all unpaired electron. Para means there are, here you have all paired electron. In paramagnetic, there should be at least one unpaired electron. And this is the formula. This is the n is the number of unpaired electron. Mu is equals to under root n plus 2. But direct trick is, here is where you use the direct trick here. That is for 1 unpaired it is 1.7, 2 it is 2.8, 3 it is 3.8, 4 it is 4.9, 5 it is 5.9 directly. Okay, understood? Yes. Achha, now see this. Now we can see spin paired, or you can also write it as no unpaired, means it is also diamagnetic. Okay. Next is, if you talk about this one, this is x minus 4 is equals to -2. That means x is equals to +2. So nickel in +2 oxidation state will be 4s0 3d8. Why? Because always electron you will take out from 4s first and after that 3d. So when I talked about nickel here only, right, it was 4s2 3d8, right? When you take out 2 electrons from here, it will be 3d8 because 2 electrons you have taken from 4s, isn't it? Yes. So now what you have next is same thing, draw D, draw S, draw P here, right? Then I'll also tell you how I will solve it for your exam. Right now I'm doing it fully in detail for you, right? 3d8 means now chlorine is a weak field ligand. No pairing it will cause. You need to know which is strong field, which is weak field. So it will not cause any pairing. So it will be 1, 2, 3, 4, 5, 6, 7, 8. Now you can see again here with chlorine it is sp3 only, right? It is sp3. Here it is tetrahedral only, but here number of unpaired electron is 2. That means mu is equals to 2.8. That means this is going to be paramagnetic. That means spin are free. Free spins are there. Free spins means unpaired spins are there. So we can say spin free complex. It is spin free. They can ask you anything related to this. Is this a spin free complex? Is this a paramagnetic, diamagnetic? They can ask you magnetic. So I'm writing everything here. Right? Okay. Okay. Now next is, so we have talked about here in this example, we have talked about NiCN6. So I'll also tell you about NiCN6 here. We'll talk about that. Don't worry. In NiCN6 now, what will happen? I'll tell you here. If you have NiCN6, where should I write it? I'll just copy paste this, right? There will be only one difference in NiCN6. Can anybody tell me? In NiCN6, what will happen? Any one of you who can tell me in NiCN6 what will happen? CN is a strong field ligand. Is it a weak field ligand? What will happen? Any one of you who can tell me? Any one of you? See, if I say it is nickel, anyone? No one, sleeping people. Huh? This is 2 negative, x minus 4 is equals to minus 2, x is this, nickel, it's the same way. Now, CN is a strong field or a weak field ligand? CN is a strong field ligand. It will cause pairing. It will be 1, 2, 3, 4, 5, 6, 7, 8. And here answer will be DSP2 because I only need 4 empty blocks because coordination number is 4. So answer will be DSP2. Here it is a square planar complex. Square planar complex. No unpaired electron. Mu is also 0. That is why it is diamagnetic in nature. But it is spin free or paired. All the spins are paired. So it is spin paired complex. Got it? Okay. Yes. Okay. Okay, so Neha, basically why it has happened, because it hardly matters, right? Even if you fill 1 1 or 2 2, it hardly does matter, right? But carbonyl is a strong field ligand. Strong field ligand. So you'll fill 1 2 1 2. You will not fill it like 1 1 1. You'll 1 2 1 2 1 2 1 2 1 2 1 2. That's how you fill, because it's a strong field ligand. In a weak field ligand, we firstly fill all the orbitals, degenerate orbitals, then we fill the extra electrons here, right? But in strong field, firstly we'll fill each orbital, like in the, we will firstly pair up all the electrons, then we'll go ahead, right? Okay, we'll get a more clarity here. Let's see here, x minus 6 is equals to minus 3. I'll just write it here. X minus 6 is equals to minus 3. X is equals to plus 3. So iron plus 3. See, tell me what is iron? 4s2 3d6. You take out 3 electrons. It will become 3d5. Isn't it? Same if I do here. It is x minus 6 is equals to minus 3. X is equals to plus 3. Iron plus 3 is nothing but 3d5. Now, if you see this here, this is a strong field ligand. This is a weak field ligand. So that is why the way we fill the electrons will be very different here. So here 1, 2, 3, 4, 5, 1, this is sp3, and then you have 1, 2, 3, 4, 5, this is sp3. See this thing, right? You fill 5 electrons, it is a strong field ligand, so it will be 1, 2, 3, 4, 5, right? Here it is a weak field ligand, so you will fill 1, then 2, then 3, then 4, then 5. Okay. Now you need 6 empty blocks, right? 6 empty boxes means 1, 2, 3, 4, 5, 6. So we have it here. It is D2sp3. Here we don't have 6 empty boxes, so we'll have to use outer orbital here. That is why we will use the outer orbital here, which says that sp3d2. Now it is sp3d2, right? That is why what we say here, it is inner octahedral, inner octa. Here number of unpaired electron is 1, so mu is equals to 1.7. It is definitely paramagnetic as well. It is also a spin free only because there are free electrons here. This is outer octa, outer octa. This is n is equals to 5, so mu is equals to 5.9. It is definitely a paramagnetic compound. Right? Okay, got it. Very good. Tell me. Done? Clear? Okay, chal. Now let's discuss this question that was asked in NEET 2017. That was about correct statement regarding Mn, Cn 6, 3 negative. So how do we fast it? X minus 6 is equals to minus 3. So X is equals to plus 3. That means manganese will be plus 3. Now manganese is 4s2 3d5. You take out 3 electrons, it will become 3d4. This is how you will do it fast in the exam, right? So now we can see this here. 4 means strong field means it will be 1 2 3 4, right? And here you will have D2sp3, right? This will be 1 2 3 4, and here you will be left with D2sp3. Because it's a strong field again, there will be no unpaired electrons, so it will be, aha, this is 4 now. So simple is in 4 dsp2, this is not possible, right? So it will be D2sp3 and it is an octahedral complex. Answer will be B is the correct answer here, right? Okay, now here see one more thing here, right? When I see this will be paired like this, now you will think, ma'am, now if I see, if I have paired this 1 2 3 4, and either the answer can never be D3sp2. This is no, there is no hybridization like this. It can only use inner two orbitals here. That means this one and this one. So it will be D2 only. That is why one electron will jump here and it will form 1 and 1 electron here, right? But it hardly does matter, but still you should know, if they ask you the paramagnetic character here, then number of unpaired electrons are 2, so mu is equals to 2.8 here, right? Okay, next is this we have discussed already. Now let's see NEET 2025 question, what they have asked you here. Let's talk about that. They have asked you paramagnetic character here. Let's see. Shall we do it? Tell me. See, firstly, what we will do? Which of the following are paramagnetic? See, here, firstly, let's see the hybridization. If you see the hybridization here, this will be X minus 4 is equals to minus 2. So it will be nickel 2 positive, that is 3d8. Definitely this will be paramagnetic, I'll tell you. This can never be paramagnetic because it is nickel 0, so it is 4s2 3d8. We have also discussed it, right? Firstly, let's calculate this thing, okay? Chalo. This is nickel 2 positive, again it is 3d8. This is nickel, this is X plus 0, this is nickel 2 positive again, that is 3d8. I'll just write it here 3d8. Okay, this is 3d8. This is also 3d8. This is 4s2 3d8. In this also it is 4s2 3d8. So wherever you have full electrons here, there you don't need to worry about that. But paramagnetic means you need to have unpaired electrons. So this is a weak field ligand. So it will be 1, 2, 3, 4, 5, 6, 7, 8. So here it will be paramagnetic. Here it will be diamagnetic with 10 electrons. So A will definitely be there. That means this is ruled out. B should not be there, right? B is not paramagnetic. Then let's talk about C. So here also it will be 1, 2, 3, 4, 5, 6, 7, 8. No unpaired electron will be there. So C also should not be there. So this is also ruled out, right? Then you have D here. In D, definitely it is a weak field ligand. It will be 1, 2, 3, 4, 5, 6, 7, 8. Right? And that's how you will have your answer here. Right? Okay? Understood now? Understood? Tell me everyone, I've just deleted, this much is not even required here. Right? Okay? This and this is same only. This is like 10 electrons only, so there is no need. 10 electrons, weak field or strong field, always in D full filled electrons will be there, right? Okay, so answer will be A is the correct answer here, right? Okay. Next question is NEET 2021. That is again based on the paramagnetic, like needs to calculate the dipole, to calculate the magnetic moment, right? So here, let's see here, it will be, see, iron is 4s2 3d6. Here it is in x plus 6, x minus 6 is equals to plus 6, it is plus 3. So plus 3 means it will lose 3 electrons, it will be 3d5. Here it is x plus 0 is equals to plus 3. Again it is 3d5. Here x minus 6 is equals to minus 4. It is plus 2. So iron plus 2 is 3d6. Okay. This is x plus 0 is equals to plus 2. It is also 3d6. Right. Now if you see here, this is a strong field ligand. So it will be 1, 2, 3, 4, 5. 1 unpaired electron. 1, 2, 3, 4, 5. I am making it for d orbital, okay? 5 unpaired, there is 1 unpaired electron, so here it will be A is 4. A is 4, A is 4, these two are eliminated, right? Then if you see B, here 1, 2, 3, 4, 5. Why? Because there is no, it's a weak field ligand, there is no pairing, so it will be 5. 5 means it will be 5.9. So B is 1. So answer will be this. Okay, answer you have. This is 6. So it is again a strong field ligand. 1, 2, 3, 4, 5, 6. It is 0. So C is 2, right? And D is 1, 2, 3, 4, 5 and 6. That means 4 unpaired electron. And that is 4.9. That is D is 3. So answer is going to be this here. Is that clear? Okay. Done. Tell me everybody. Tell me, right? Okay, so now before moving towards CFT, right, just give me 2 minutes, I'll be back here, and you also let me know what we, by the time I am back, just give me 2 minutes, just tell me one thing, what do you mean by these d orbitals here? Okay. E option, A1, because A is not 1. A is getting out to be 4. That's why, right? Okay, yes. Now let's see this thing here, because in the d orbitals, dxy, dyz and dzx are between the x's. These are between the x's orbitals, and these are along the axis. So what you will see in the CFT theory, when all the d orbitals are degenerate, when the ligand is coming near to them, there will be rise in energy, and after that there will be splitting of the d orbitals, right? And in case of octahedral complexes, the splitting of d orbitals will be like this, where upper will be Eg and lower will be T2G. Lower will be between the axis and upper will be along the axis, right? Okay, and here you will also see one more thing. Here it will be plus 3 by 5, it will be minus 2 by 5, right? So this is the barycenter that you will have here, right? Okay, so when you fill the electrons, let's say I have a weak field ligand. Let's say I am talking about only one thing here, that is D4. So D4 can be of two cases, right? D4, two things can be there. There can be strong field ligand, there can be weak field ligand. In the strong field ligand, there will be pairing, so it will be 1, 2, 3 and 4. Because the gap is very high. Strong field means this gap is very large. So pairing will happen. Right? In this case, you will have T2G4 and EG0. In the weak field ligand, what will happen? Here it will be 1, 2, 3 and 4th will be here. So in this case, it will be T2G3 and EG1. Right? So that is the difference that it will make whether you have strong field or you have weak field here. Right? I hope so. That is clear to all of you. Right? And to calculate the energy, this I have told you that it will increase, it will decrease. To calculate the energy of the orbital, number of electrons, to tell it in a better way, we can write it. Wait a minute. Give me a second. We can write it like this. Wait a minute. It can be written as a minus 0.4 into number of electrons in T2G plus 0.6 into number of electrons in EG. That is the formula for calculating CFSC. This also they ask you. Right? Either they ask you the configuration like this. In this you have strong field, weak field. What is the configuration? Or they directly ask you the this thing here. Now one more thing here, right? For weak field, strong field, there are certain things that we can talk about. I think it's already written here, right? See, so if I talk about weak field ligand means the gap is very less. That means delta O is very low. Delta O is very less. Here that means delta O is very high. So that is why in a weak field ligand gap is very less. That is why pairing will take place here. Sorry, in a weak field ligand no pairing take place. No pairing. Here in a strong field ligand pairing will take place. Right? And here we say, because it's a weak field ligand, that is why in the weak field ligand you can see this over here, that in the weak field ligand when you do 1, 2, 3, 4, the highest more spin, more unpaired spins are there. That is why weak field ligand is called as high spin complex. So I will just write it like this. Okay, wait a minute, this will be a better one for you. Wait a minute. I think ऐसे ना you will not be able to remember this, right? But the way I'll write it, you will be able to remember this, right? Okay, see. Two things are there. If I say there is a strong field ligand, then there is a weak field ligand. In a strong field ligand, CFSC is very high. That means the gap is very high. Because the gap is very high, that's why pairing will take place. Or you can just write here pairing. Pairing will take place here. Because pairing will take place, that means less pairing energy is less than delta. Because here pairing is taking place, that is why it is a low spin complex. So these are all the different names. They can tell you low spin, they can tell you strong, they can tell you pairing, they can tell you P is less than delta. That means the same thing, right? In this CFSC is low, that means gap is low. That means no pairing will be here, right? That means pairing energy will be greater than delta O. That means it is going to be a high spin complex. Okay. Now this we have already done. Now let's see, for this also we have done already, right? Now for tetrahedral complexes, it is opposite. On the higher energy side, you have 3 orbitals between the axis, and on the lower energy side, you have E. And in tetrahedral complexes, you don't write G because there is G for gerate, that means symmetry. In tetrahedral complexes, now what you will see, if I talk about the factors affecting here, you will see one thing here, that is, wait a minute, it is not written here, kya? Yeah, it is written here, wait a minute, yes. So if you see, factors affecting CFSC. In 5D, it is maximum, then 4D, then 3D. In 5D and 4D, CFSC is so high, the gap is so large that always it will form. Like as you talk about 4D and 5D series, the gap is so large, the CFSC is so high that always it will form low spin complexes. Always low spin complexes are formed. Always pairing will take place here. No matter what. No matter what is the atom, what is the ligand, is the ligand strong field, weak field. In case of 4D and 5D, pairing will always take place. Reason being, their CFSC is very high. In square planar, you don't have it in your syllabus, but octahedral is greater than tetrahedral. And you can also see that tetrahedral is about 4 by 9 of octahedral. That is approximately half. And you know, that is the same reason. That is the same reason, right? I'll just simplify this for you. That is the same reason tetrahedral complexes always form high spin. Why? Because it is less than octahedral. It is so less that pairing rarely takes place here, and the electrons will always go above. That is why always high spin complexes are formed. Usually, I'm not saying always, but generally it forms high spin complexes, right? Then we see, this we have discussed. Then let's discuss about the charge here. The charge on the metal ion increases with increase in the ligand, right? So more is the charge. Beta, this now let's delete this page only. Essay, you will feel that more things to learn. So I'll just write it here only. If I talk about metal 3 positive, it will have more CFSE as compared to 2 positive, as compared to 1 positive. Reason being, more is the positive charge, more will be the electrostatic attractions, and that's how it will go, right? Okay, tell me everybody, am I a Pookie ma'am? Okay, tell me everyone, is that clear? Acha, now this one is the spectrochemical series from where directly the questions are asked. Okay, directly they ask you questions from spectrochemical series. I'll tell you how. So this is a full series and this is how you learn it. They ask you the order of the series directly. Now you can see why I told you carbonyl is strong field ligand, because it is highest. Then cyanide is also strong field ligand because it is highest in spectrochemistry. This is also highest. Ammonia, sometimes it is in the borderline, sometimes it will behave as a strong field, sometimes weak field. Right? Now this is a direct question, which is the correct order of increasing field strength ligand from the to form the coordination bond. This is a direct question here. You can see answer will be D. This is directly from the spectrochemical series. Directly. Okay, there is no need, you just need to learn the spectrochemical series and that's it. Okay, this is, these two complexes are octa. This is NEET 2024 question, that is these two complexes are octahedral but differ in their magnetic character. Yes, they are octahedral. This means cobalt, both are cobalt plus 3, right? That means cobalt plus 3, cobalt is 4s2 3d7 plus 3 means it will be 3d6. Okay? Differ in the magnetic behavior. Yes, magnetic behavior will be different here because here it is acting as a strong field ligand. Here it will act as a weak field ligand. So here pairing will cause, it will be 1, 2, 3, 4, 5, 6. Here it will be 1, 2, 3, 4, 5 and 6. So definitely magnetic behavior will be different here. Then this is diamagnetic, definitely yes. This is paramagnetic, that is also true. So we can say both the statements are true. Yes, today we are expecting, guys, JEE ka, that you are saying, we are definitely expecting it today itself. Right? Okay. Now let's see the next one. What is the correct order of electronic confidence centimeter? That is this based on crystal field theory. So if you see, this is K4FeCN6, right? So here it is. This is 4, so it will be minus 4. So this will be plus 1. That is why it is X X minus 6. Cyanide is minus 1. So it is minus 6 is equals to minus 4. So X is equals to plus 2. They are asking you iron plus 2. Iron is what? Iron is 4s2 3d6. Iron plus 2 is nothing but 3d6. Okay. For octahedral, it is always 1, 2, 3, 1, 2. Right? So they are saying this is a strong field ligand. Okay. This is a strong field ligand. So it will cause the pairing. So it will be 1, 2, 3, 4, 5, 6. So it will be T2G6EG0 is going to be your answer here. That is B is going to be the answer here. Remember, this is a strong field ligand. That is why the answer is going to be B is the correct answer. Yes, B is the correct answer here. Right? Okay. Tell me, everybody. Do let me know in the chat box. Then we talk about the color of the coordination complexes, from where again the questions are asked. So color happens because of the DD transition. If you see here, there is one electron, it will shift to this position and it will come back, and complementary color will be given by this compound. So every compound has, for example, it is absorbing violet color, it will give you yellow. It is absorbing green, it will give you red. It is absorbing orange, it will give you blue. And based on that, complementary, this is called as the Munchel wheel, right? So it is a color wheel. So based on that, colors are given here, right? Now next is, at this point some students also remember these colors, but I would not advise you to do that. Reason being, right now is not the correct time to learn the colors, and very rare chances, it's not like chances are not there, but very rare chances are that they will ask you color, right? So if you ask me, if you have met me 3-4 months before, I would have advised you to learn the colors as well, but now I will definitely not advise, right? Okay. Now let's see this correct order of wavelength of light absorbed by the following complexes. See, energy is inversely proportional to lambda. Energy you can see here. This has maximum strength here. So B should have the minimum one, right? If you see water, wait a minute. Correct order of wavelength of light is falling complexes is what? This will be depending upon the ligand strength, right? So if you talk about the ligand strength here, right? This all belongs to copper. This is titanium. Titanium is actually that is 22 atomic number, right? So here what we can do, first thing is, this is tetrahedral. Okay. First thing, it is tetrahedral. So tetrahedral definitely has lower as compared to octa. This is octa, this is octa, this is octa. Right? So C definitely will have less. So C is less only in these two cases. Now if I compare water, ammonia and this, CN has maximum maximum in the spectrochemical series, then you have ammonia, and then you have water. So this is the order of energy. So lambda will be opposite here. Cn minimum, then NH3, then you have water as maximum. So here D will be maximum. D is not written out to be maximum here. Wait a minute. Okay. This is cobalt plus 3, that is also plus 3, here also it is plus 3, right? So this is water here. They're asking you lambda, right? So lambda, okay, so let's just see this. A and B should have, oh, have I written it opposite? I have written it opposite, guys. I'm so sorry. I'm so sorry. I have written the value of, even I got little bit confused here. Just a minute. If I see the energy value here, energy of tetra will be minimum. That means its lambda will be maximum. That means C will have maximum here. So these two are eliminated. Okay? Yes. Now if I compare A and B here, in this case, water will have maximum. Water means D will have, then you will have, after water, you will have ammonia, that is A, and then you will have B. So answer will be D. Okay? Yes. I just wrote the order of wavelength energy here. They are asking you the order of wavelength, that is opposite to energy. Okay, so that will be this much order. You should not, like, you don't need to remember, just do it from the spectrochemical series only, right? Okay, next one is your metal carbonyls. Now this is also a very small topic, right? In this case, usually metal has the ability to accept and ligand has the ability to donate, but in this case opposite will happen, right? Ligand will start accepting from the metal and they will accept in their pi star. This is very important. Ligand have the ability to donate, but they start accepting in the back bonding from the metal, and that is in the anti bonding orbital they will accept. In this anti bonding, this diagram you don't have to remember, just remember in the anti bonding orbital they will accept. Extent of this back bonding is proportional to negative charge on, more is the negative charge on this and less is the positive charge on. That means if positive charge increases on CMA, then see, if metal wants to donate, electron density has to be high. For high electron density, negative charge should be high, positive charge should be less, right? Then another thing is, due to back bonding, what happens? Strength of MC bond. See, this is M and this is donating to C. So if this strength increases, because more is the back bonding, this strength will increase. Then this particular, if this is increasing, this will decrease, right? So if this strength is increasing, we can just write it here. One more thing here, you don't have to remember all of this. I would just, okay, this you can just remember, but the easy way out is bond strength, more is the bond strength, less will be the bond length. More will be the bond strength, more will be the bond order. Right? So if I say here MC bond strength is increasing, its bond order will also increase. That is why its bond length will decrease. Now because here its bond strength is decreasing, so its bond order will decrease and its bond length will increase. Okay, this I am talking about strength. I am just giving you easy way out here. Just remember here strength is increasing, this is decreasing, and this is the proportionality here. That's it. You will be able to, you don't have to remember these lines here, right? Okay. Now these are some of the important structures of carbonyl, as you can see, right? Nickel carbonyl compound. This is tetrahedral. This is trigonal bipyramidal. With chromium it forms octahedral. Now these two are very, very important. With manganese there is one MN-MN bond and it is two octahedrals getting connected with each other, right? In this case, what you have, this is again very, very important. With cobalt, there is one bond of cobalt and cobalt. There are two bridged ligands, bridged, this is forming a bridge now, so two bridged carbonyls, and there are three terminal, these are, sorry, six terminal, 1, 2, 3, 4, 5, 6 terminal, and there is one metal bond as well. Okay, there is this metal bond as well here. So this is very important structure. Directly from the structures they ask you the questions, right? Okay. NEET 2024, they have asked you question based on this structure, that is metal linkage. They are saying metal, which of the structures has metal? Both have metal linkage. Okay. Both structures have metal linkage. They have terminal, both have terminal. This has bridging carbonyl and terminal as well. This has bridging also and terminal also. This only has terminal carbonyl. Okay. So bridging carbonyl are not there in both. Metal in zero oxidation state is also in both. So A, B, D is there in both the cases. So answer will be D is the correct answer here. Right? Okay. So if you know the concept easily, you can do this within seconds. NEET 2022 question, that is assertion is metal carbon bond in metal carbonyl possesses both sigma and pi character. Now metal carbon bond in metal carbonyl possesses sigma and pi character. Yes. Ligand to metal bond, ligand to metal is a pi bond. Metal to ligand is a sigma bond. That is not correct. Metal to ligand is a pi star anti-bonding. So we can say assertion is correct and reason is not correct here. Right? So answer will be D is the correct answer here. Right, everybody? Tell me. Now the last part of this chapter is isomerism, which I'm gonna tell you in a fast forward manner. Just spam it in the chat box if there is any problem till now. Okay, tell me everybody. Tell me, bacha, everyone. Neha, Murti, Dishi, Avila. Tell me. Acha, now let's do the last part, that is isomerism. So two kind of isomerisms are there in coordination chemistry, that is structural and stereoisomerism. In structural isomerism, these are the 4-5 categories that we have. Let's discuss. Ionization isomerism means when the counter ion and the ligand exchanges their position, that is ionization. Hydrate solvent isomerism means when the number of water molecule acting as ligands are different, like here you have 6, here you have 5. Then linkage isomerism is when you have bidentate ligand, and here it is donating from nitrogen and here it is donating from this oxygen, that is called as linkage isomerism. Then in coordination isomerism, when you have two coordination spheres where the ligands are getting exchanged between the two coordination sphere, that is called as coordination isomerism. Right? Ligand isomerism, this was linkage. Okay, this is ligand isomerism. Ligand isomerism, When the ligands are isomers of each other, that is called as ligand isomerism. Coordinate position, they don't ask you in NEET, they don't ask you this, so you can also skip this. Okay, you can also skip this, but uh, as it is already written here, so I'll just tell you here what happens. You have two metals, and these two metals exchange their ligands. Like here you have 4 and 2 ammonia and 2 chlorine. Here you will have 3 ammonia and 3 ammonia here and 1 chlorine here. So basically two metals, they will exchange their ligands. That is called as coordination position isomerism. Right now, based on this simple thing here, based on this simple definitions, they have asked you question in NEET 2024. That is, if you have this is bidentate, clearly we can see that is why it is linkage isomerism. So A is 2. A is 2, you can see it here, you can see it here, other are eliminated. Then here you can see, here it will show counter ion will be exchanged. Bromine can act as ligand as well. So it will show ionization isomerism, right? So B is 3, right? Then you can see this is coordinate isomerism, C is 4, and this one, because water as a ligand, so definitely it is hydrate or solvate, that is D is 1. So answer will be A is the correct answer here, right? Now let's do next one. Again, now this one actually, this has, let's see this. The type of isomerism exhibited by these and the value of coordination number. See, it is water, 6 water, then 5 water as ligand, then you have 4. That means it is definitely solvate isomerism. Coordination number is always 6 only, right? Here also it is 6. You can see bracket will be here, right? Here also it will be 5 and 1 Cl will be here, right? So here also it will be 4, 5, 6. So you can see always the coordination number is 6. So answer will be D is the correct answer here. So these are very, very simple questions. You can see 2023, 2024, they are asking you, you just need to know this concept and that's it, right? Okay. Now the last topic here, that is your stereoisomerism. Now see, in stereoisomerism, it is fixed, right? The questions that they ask in NEET are fixed. Fixed means same question they are repeating again and again. Same compound they are repeating. So that's why in this part, see, although you can watch my lecture 3-4 on Vedantu J English, you go and you can watch my lecture 3-4 hours. Like the concept is same in NEET and JEE, right? You can watch my lecture if you want to go through that in detail. It's a 3-4 hour lecture. I have shown it with the help of shapes and everything, but that is not needed here, right? So I'll give you directly which shows and which does not show, okay? That you should remember for the exam, right? So geometrical isomerism means cis and trans. So cis and trans will be shown by square planar or octahedral. Tetrahedral will not show this. It will never show geometrical isomerism because opposite and same you can never tell in tetrahedral. If there is any tetrahedral complex, you will never be able to tell. Now, can you tell me these two are next to each other or opposite? Chalo, if ma'am, now they are next to each other. Okay. If I place it here, now tell me. Now tell me. This way it will seem opposite, but this way they will seem next to each other. So that's why you can never tell whether it is cis or trans, right? In optical isomerism, tetrahedral will show, octa will show, but square planar will never show. This is the question that they ask, which of the following can never show optical, which of the following can never show geometrical, right? Okay. In optical isomerism, what you need to have? POS should be absent, only then optical isomerism will exist. Plane of symmetry should not be present here. Now, in this case, whenever I write AABB, that means I am talking about symmetrical bidentate. If I write AB, that means I am talking about unsymmetrical, which will never have POS, that kind of ligands. Right now, see, in geometrical isomers, Cis means when two are next to each other, when two are opposite to each other, that is trans, right? Now, if you see for coordination number 4, what are the compounds that shows geometrical isomerism always? So, if you see, these compounds will never show GI. All these compounds, Ma4, Ma3b, MaB3, MAA twice, MAABB, MAAAB, they will never show any geometrical isomer. Take a screenshot of this one. Then coordination number 4, this one will show Ma2B2 will always show. These are next to each other, so it is cis. These are opposite to each other, so it is trans. They will always show, right? If you see Ma2BC, again E and A are next to each other, so it is showing. A and A are opposite to each other, so it is not showing, that is trans. Sorry, it is cis and this is trans. It is also showing. Next example is one of the famous examples, that is MABCD. Here always you will have 2 cis and 1 trans. Remember it as it is. They ask you very frequently this thing. So if you see this over here, this is, let's say this is M A B C D. So I will fix A here, right? Now when I fix A here, I will exchange other two. B and C I'll exchange. This is C, this is B, this is D. Now again I have fixed A only here, right? I'll exchange D and B. So this is C only, this will be B and this will be D. Now what you will see, you will assume two to be similar. For example, if this is the compound, I'll assume bromine and chlorine to be same. Here let's assume B and C to be same. B and C to be same. B and C to be same. So you can see this is cis, this is cis, this is trans. Anything you can take as same, always you will have 2 cis and 1 trans. Always. Okay? Now in AB twice, these are opposite to each other. So trans, this is next to each other. So it is cis. Right? Now no GI in coordination number 6. No GI is shown by all these cases where no geometrical isomerism will be there. If I say Ma4B2, very important this one. This will always show this is next to each other, so it is cis. This is opposite to each other, so it is trans. Very famous. This is a very famous example. If you see A3B3, again very important because this shows something else. This shows facial and meridional. Okay, see. Facial means they are all in 3D, it is something else. In 3D, we say facial means on one face, right? If I talk about this thing now, wait a minute. On one face now, it means this thing. This is one triangular face. Okay, facial actually means one triangular face. That is why it is called as facial. But in 2D, we write it when E is next to each other, that is facial. And meridionals is actually when they are forming hemisphere, right? This is forming a hemisphere, so that is your meridional. Okay, so in this case in 2D, how we will write it? A, then leave one space, then A, that is meridional. This is a very famous one. They ask you this very frequently. Okay, then A4BC, you can see C and B next to each other, so it is cis. This is C and B. This is opposite to each other, that is trans. We just need to differentiate it. Okay. Now this is again a very famous one here. Usually they give you En twice here and this is Cl. Usually this is the example they give. Now when En is next to each other, that is cis. When En is opposite to each other, that is trans. This is again very famous. Right? These are next to each other. These are opposite to each other. Right? Okay. Next. Now this is the full data here. You can see if you have A, B, C, D, E, F, all are different. Then you will have total 15 geometrical isomers. Okay. This is the full table and chart here. Now if you see this here, the type of isomerism shown by this complex. This shows which type of isomerism. This will show, we can see cobalt 1, 2, 3, 4, 5, 6, En, this is Cl. So this shows you geometrical isomer, this one, and it can also form 1, 2, 3, 4, 5, 6, En, Cl, Cl. This is cis and this is trans. So it shows you geometrical isomer, right? Okay. Let's do optical isomer. In optical isomerism, you should not have a plane of symmetry, right? This is another way of telling it. So when I talk about plane of symmetry should not be there, let's see the examples here. In coordination number 4, that is that we talk about, in this case, optical isomerism is shown by MABCD. Okay? I'm just writing which shows, and it is shown by MAB twice. Okay? Others will not show optical isomer here, right? In coordination number 6, you will see optical isomerism is shown by MA2B2C2. Okay? Then it is shown by MABCDEF, right? You can just go through this. So I'll just tell you now, these are the general things that I told you that which will show. This is fully I have written, but you just remember which will show. Now I'll give you some examples here. For example, you have MEE twice. Now this is one of the famous examples of NEET that they ask you again and again. So in this case, let's say this is X, this is Y, this is Z. Or I'll just tell you to do this because I have a space here. This is X, this is Y, this is Z. So if I take the POS, means they should be non-superimposable mirror images. So if I say, if I take the mirror image, this will become X, this will become Y, and this will become Z, right? Now if I rotate it, this is Y, this is X, this is Z. Now if I rotate it, this is mirror image, right? Now if I rotate it to 180 degree, that means I can do it like this. 180 means this X will go opposite, this Y will go opposite, this Z will go opposite. This Y is overlapping with Y, X is overlapping with Z, and Z is overlapping with X. So they are non-superimposable mirror images. That is why this will always show optical isomerism. This is important. If you don't want to know the detail of it, just remember that it will show. Just remember that. Okay, if you're not able to understand this, this is not the point to understand things in that much detail. Just remember this will show optical isomerism, right? Okay. Acha. A8 twice B2. If you see two cis, one cis and trans, it was forming. As I told you, this is one of the famous questions. Now this cis isomer, right, and trans isomer you have, and cis will show optical activity, trans will not show optical activity. Okay? Aha, this is to cis only, na? Cis will show optical isomerism here, right? Cis will show optical isomerism, trans will not show. Cis will show here. This is very important. Okay? Understood? Chalo. Then you have MAAB2C2. Whenever you have this kind of compound, always remember cis will show and trans will not show. Trans usually does not show because trans usually easily you can find the mirror images in trans. Okay? Now this is a full table and all. Now let's look at the questions, what kind of questions they give you. In AIPMT, the number of possible isomers of the complex. Again, I told you it is a repeated question, right? So it is cobalt. That's why I have directly given you what to remember, what not to remember. So they will give you how many possible isomers. First thing is it will form cis and it will form trans. Multiple times we have done this. Trans will show optical isomer. This will not show. So total it is 1 cis and 1 trans, and cis is going to show optical isomer. Overall it is 3. So answer will be 3 is the correct answer here. Right? Then they are saying chiral complex form the following. Chiral complex means which has chiral complex. Wait a minute. Ethylene chiral complex is optically active. They have asked in a different manner, right? So AC, optically active you are looking for. Optically active, out of these are trans, so will not be correct. Okay. Cis can be. Here it is cis and here also it is cis. So complex of the following which is optically active. Wait a minute. If I talk about this cis here, wait a minute. This is PT. Acha, this is to Cl to NH3. This is coordination number. This is cis, na. So this is actually PT. This is 1, 2, 3, 4 Cl, Cl. This is NH3, NH3. It will have a, again. It will also not show because this is square planar Ma2B2. As I have told you, PT. This is Cl, Cl, and this is NH3, NH3. It will definitely have plane of symmetry. This one does not have. This will show optical isomerism, right? So answer will be A is the correct answer. Next is indicate the complex ion which does not show any geometrical isomer. See this, so we have seen multiple times that this is showing. How many times? Hai na? This is showing. This is 5 and 6. This Ma5B will not show geometrical isomer. This will also, this will show facial meridional because it is A3B3, right? This one will also show because it will be like M, this will be 2 chlorine here and 4 ammonia, or you can have 2 chlorine next to each other and 4 ammonia here, right? So that will also show, this will also show. This is not going to show. This is Ma5B complex which does not show geometrical isomer, right? Okay. So see how quickly, right, we were able to do these questions. So what you need to do is you just need to know the concept here and easily you will be able to do the questions based on coordination chemistry. It is definitely not a difficult chapter. Isomerism students get confused here, and that's why I'm telling you same questions are repeated. Wherever I have written important, that is important for your NEET exam. Right, from my 9 years of experience I am telling you this, right? If right now you don't have time, then where I have written important in the isomerism, do that. Okay, yes. Okay guys, so that's it for today. My actually head is paining a lot now, so I'll take rest, and all the best for your upcoming day, right? Utilize it properly. Saturday and Sunday means a lot for NEET aspirants, so utilize it properly. Two chapter chemical bonding, coordination chemistry we have done, right? And also let me know in the comment section what chapters do you want me to pick in the next time, right? So that's it for today guys. Bye bye, take care, see you all, bye bye.